So to kick things off, I'm Archana Kamath. I am the San Jose chapter lead for WISE. And let me introduce the WISE co-chair, Shweta Saraf, who's going to give you the welcome note and kick things off with a small video.
Thank you so much, Archana. So first of all, a big thank you for everyone to making it on your weekday, battling the traffic. So we have some nice food for you in the back, so please go ahead and enjoy it. And we have a packed agenda for you today. So we will be starting with what our vision for WISE is, what is Women in Science and Engineering doing at Cisco with a brief video, and then it will be followed by code checks and our speaker for the day, who will be Anne Medved talking about SDN. So without further ado, Carolyn, I'm gonna request you to just roll off the video.
I am a female engineer. I love to do what I do, and I would love to have more female technologists join me. If you like logical reasoning, if you like problem solving, this is the career for you.
WISE is really an employee resource group which is driven by a passionate group of women. Our focus is really to encourage women empower their own career.
I joined WISE because I'm passionate about giving back to my community, and we are seeing shortage in IT field for young girls, and we really want them to empower. We want to be role model for them.
My favorite part about being in WISE is I'm able to communicate to women globally. We just started a chapter in China, and they are already more than 100 members strong. One of the most popular events that we have is Women in Technology Professional Development Series. It's a monthly event where we really bring in speakers from within Cisco or externally to talk about various topics like technology, how to present.
One of the events that we have had till now is called Cookies with Cisco. So we had universities like Penn State and UIUC remote dial-in through telepresence. And we had a panel of women technologists kind of talking to the girls.
I was in my own cocoon, and I broke the shell and started exploring my potential. That passion just grew to give back, and that's why I feel there are many more people who may want this help, and that's why WISE as a community exists. So with that, I'll hand it back to Archana, and a few logistic things. You are welcome to tweet throughout the event. You can use WITF as the hashtag, or you can use Cisco as the hashtag, and code checks as a hashtag. So feel free to add to that, Rupa. And we are also doing video testimonials at the end of the event. So Ken, our videographer, is right there. You can go just say some words to him at the end of the event if you like to. And please stick around for raffle as well. We have some exciting stuff for you.
Thank you, Shweta. With that, I'd like to call Rupa, the cherry on stage. She's the founder for CodeChecks. Welcome.
Thanks, Archana and Shweta. That was great. So I have a few slides, so I'm going to have to transfer the video over. Hang on one sec. Okay, so first of all, good evening, everyone. Thanks for, once again, as Shweta mentioned, battling the traffic to come here on a weekday evening to hear us talk about SDN and learn a little bit about it. So this is the first joint event that we're having with WISE and CodeChecks, and we are extremely excited to be here. and thank you for coming. So today I'm going to share a little bit about what CodeChicks is and what we do. And after that, I'm going to introduce Deepa Karna-Durga, who is a CodeChicks member and an organizer. And she's going to be talking to you a little bit about OF Connect, which is a CodeChicks open source library for OpenFlow. So as you all probably know, there is a 56% dropout rate for women engineers in industry over the first 10 years. CodeChicks is a nonprofit that is trying to address this problem and to increase the number of women engineers in industry. And the way we plan to do this is through ramping up, through educational classes, opening up through participation in technical conferences and technical public speaking, and also by pairing up through bringing together women engineers from different industries and different companies to build tools and technologies. So in short, CodeChicks is dedicated to the education, advocacy, and mentorship of women engineers. We're founded in 2009, and we have 3 chapters. We have the Bay Area chapter, which is a flagship chapter, and we have a chapter in Seattle, and we have a new one coming up in Madison, Wisconsin this year. We are completely volunteer run, and we run on donations and grants. And we would love to have you join us and contribute to our projects. So if you're interested in volunteering, please contact us. These are some of the educational programs that we currently do. We have workshops which are open to everybody. These are typically instructor-led and hands-on. You come with your laptop and you sit there and you either code, sorry, or you learn about a technology through using it. We also have technical talks. Sorry, my throat is just killing me. Technical talks like today's, where we have principal engineers or executives come and talk about their projects or their programs, and we encourage them to show code and, if possible, do a demo. And the third type of program we have are hacking sessions, which are informal get-togethers where women bring their side projects or their homeworks or even work and get together and work together. So 2014 so far, we've had about 16 events, things including, thank you, Java, Python, C# classes. We've had a Google Glass workshop, Android UI and fragments technical talk. And we have just released the CodeChicks open source GitHub repo, which houses 3 fantastic open source projects. MapViz, which is a visualization tool for geographical data. OF Connect, which is what Deepa is going to talk about. It's our CodeChicks open source library for OpenFlow. And PyDoorbell, which is a home automation tool for detection of events and notification through SMS. All of these are open source under very liberal open source licenses. So if you're interested in contributing, we would love to have you come and contribute to our open source projects. Feel free to contact us again, if you want to become a contributor. Go check it out. It's CodeChicks open source under GitHub. We were also at PyCon 2014 this year in April, where we did our first tutorial at a technical conference, and that was to teach people about Raspberry Pi and also help them get started on building PyDoorbell by themselves. And this included Raspberry Pi and a proximity sensor and breadboards with jumper wires, etc. And it was one of the best tutorials at PyCon 2014 this year. And we also had 6 proposals to Grace Hopper this year, and so far I think we have 2 acceptances. So some upcoming events. We are planning on doing a follow-up event to today's technical talk that Deepa is going to talk about, OF Connect. We're going to do a hands-on workshop on it where you can come and learn how to use it and learn a lot about SDN through looking at the code and using the code. And as I mentioned, we're going to be at Grace Hopper. We'll probably have a booth there, so if you're going to be there, please come, say hi. So we just became a nonprofit this year, and we're very small, completely volunteer run. In fact, everybody has a full-time job, and this is something we do on the side. So we have currently a lot of needs. Some of them have to do with sponsorship and funds to grow our organization. We are also looking for chapter leads and organizers for San Francisco, so we can have a separate chapter there, and organizers for Silicon Valley. And as I mentioned, participation in our open source projects through contribution from women engineers is going to be huge. So please, if you're interested, do come and talk to us. We're always looking for technical speakers and workshop leads. So if you know of someone, or if you're interested in speaking about a technical topic or giving a workshop, we would love to hear from you. And we're looking to expand to other geographical locations, whether it's in the US or outside the US. So if you know anyone who would be a good chapter lead, who's very technical as well as has some organizational talent, please let us know. And you can let us know through email at organizers@codechicks.org. And we're also on pretty much every social media channel possible. So we're on Twitter, as Shweta mentioned, at CodeChicks or #CodeChicks. Google+, Facebook, Meetup, and we also have a YouTube channel with some of the videos of our events that we've had over the last 5 years. And we are delighted to have Cisco as our platinum sponsor for 2014. This sponsorship was fundamental to getting us to the nonprofit status, and huge thanks to this awesome company for supporting us. Thanks especially to Serpil, who's sitting right there, Monique, Kristen, and David for making this happen. If it hadn't been for them, I don't know, it would have come out of my pocket. And it was a lot of money, so thank you so much. And last but not the least, the motto for CodeChicks is, "May the code be with you." Once again, thank you for coming and showing your support. And with that, I would like to introduce Deepa, who's going to talk a little bit about OF Connect. Deepa is a senior software engineer at Ericsson with over 10 years of experience in network technologies spanning Layer 2, Layer 3, VRRP, and VoIP. She's the technical lead and project manager for CodeChicks OF Connect, an open source library that manages OpenFlow channels. Deepa enjoys creating embedded projects and is currently working on an irrigation system with capacitive moisture sensors. She's an active member of CodeChicks and has a deep commitment to supporting women in programming and technology. She has a master's in electrical engineering from the University of Southern California. So please welcome Deepa Thurka.
Thank you, Rupa. That was a great introduction. I didn't expect it. Thank you. So today I'll talk about OF Connect. What it is a shared library that manages network connections for OpenFlow. And OpenFlow is one of the ways the SDN controller and an SDN switch can talk to each other. So OpenFlow, a point I needed to make was OpenFlow is a protocol that is supported and that's provided by a foundation called Open Networking Foundation. And this is important because it's very tightly connected to what we have achieved in 2013. So in the next few minutes, I will talk about what we have accomplished in 2013 for OF Connect. And as I said, it is mainly to do with a competition that ONF hosted. I'll also talk about the open source code that Rupa alluded to and the license that it's against. And we have plans for 2014. I'll go over that and how you can all join and contribute. Yes. That's okay. So in April of 2013, ONF announced a competition for an OpenFlow driver. Now this is what is shown in the blue box right there. The scope of this is pretty much to manage the OpenFlow connections, to hide the transport layer protocols, and to be compatible against multiple variants of OpenFlow. That was basically the functional requirements of this driver. For the competition itself, there were a few more requirements, and this included multiple language bindings. Essentially, it required us to write in an efficient language like C or C++, but then have bindings on Java and Python, or, for example, those are just examples, or 2 other languages. Platform independence on x86 or other architectures. And the most challenging bit of this, and also I think the most exciting bit, was the full SDN demo. What this means is that for us to enter the competition, we should have had not just built the driver, but also integrated that into a working controller and submitted it for judging and testing purposes. So this competition was announced around the same time, actually at exactly the same time that OpenDaylight came on the scene, and SDN had pretty much burst into the scene. So I was very excited, and I wanted to be a part of the SDN scenario and do something very hands-on with it. And a competition like this seemed a perfect avenue for getting into SDN. But very clearly, I couldn't do this on my own. And for various reasons, I couldn't do it through my company. So then I approached CodeChecks and proposed that we could submit this entry via CodeChecks. And within days, we had a really excited team on board. We worked really hard to get IP property rights waived from each of our companies. Essentially, each of our employers waived the right to the code that we wrote, which in itself, I think, is one of the ways companies can donate and promote such work. And 3 and a half months later, we had our official entry to the ONF competition. So this was us on submission day. You see the jubilation on our faces. And I can tell you that it was not just because we entered an international competition. It was because either way, regardless of whether we won or we lost, we were now part of the open source universe. And this is a huge deal. It is a big deal because women, the representation of women in open source right now is at 2%. It's meager, and any project like this, any signal like this that encourages more women to come on board and be a part of this world, I think is a step in the right direction. So that was us right there. You can see our companies who were generous enough to let us work on this, and that was the team. So what did we create? I showed this image to you earlier. This was what the competition required, the blue box. Essentially, that translated into what we call the OF Connect library. But that wasn't enough. We had to create unit test automation, and this was necessary to really speed up on our integration testing and to make the entry even possible. The third thing we created was, it looks like one piece of the jigsaw puzzle, but it was a lot of work. It's an entire SDN controller that is currently fully operational, called Mool. But what we had to do was plug in OF Connect into Mool and submit that as part of the entry. So to kind of clarify this point, every controller and switch has its own custom code that does pretty much what we do today with OF Connect. The difference is that OF Connect is a shared library. So if some new development is happening, a new controller or switch is being developed, it can leverage the work that's done in OF Connect and leverage on the time to market and cost of entry kind of things. So we got the Mool controller ready by tearing it apart and plugging it in with our OF Connect. And finally, we had our SDN setup. And the SDN setup was end-to-end with controllers, with virtual switches, and this was hosted on the Amazon Cloud setup. All of this, along with the boatload of documentation, is what we had completed to accomplish in that amount of time. To give the next level of detail on the design, I just want to show the sequence diagram for the API. I'll just go over a few points here, not everything. For one, if you notice to the far left, you see the SDN controller, and the far right is the switch. And OF Connect library can be used either by the controller or the switch. The second thing I want you to observe is all the socket calls are subsumed by the OF Connect library, which is one of the goals of this library, which makes the controller and the switch not have to, it hides the transport layer stuff that the requirements included. The third thing is the OpenFlow setup. Currently, the setup is still done between the controller and the switch, but as the next phase, we want to fold that into the library as well. So once the controller initializes and starts up, it can directly start to send and receive OpenFlow packets. So this was a peek into the API. So overall, in the end, this was a competition, and we were finalists. We were in the final round of the judging rounds, but we didn't make it. We didn't win. What that means is CodeChicks is now the owner of all the code that we had entered, and we can take it anywhere we want to with a lot more development and a lot more work that can go into it. It's just a lot of potential. And just as of last week, CodeChicks open sourced OF Connect on GPL v2. We have the other repo as well, which is currently private. We have no plans of open sourcing it as yet. It's meant for testing purposes. So it's important to note what we learned out of this exercise. We wanted to be hands-on with SDN. We accomplished that. We wanted to build a system grounds up. From 0 lines of code, we went to 10,000 or more lines of code in 3.5 months. I think that says a lot in itself. And collaboration, this came for free. We had to learn this. We had to learn how to collaborate the Git repos and make sure the commits are, the sanity is correct on the commits. I can drone on and on about the technical details of whatever we've learned. But what's most important is that we made it happen. And if I think back, these are some of the reasons it was even possible. There was a spirit of research and self-study. There was a very positive vibe in the team. There was a whole lot of passion, and the get it done attitude, it can never be underrated. We were jumping in, taking on tasks, we were helping each other out. It was just very positive and very amazing, and that is what made it happen. So now that we have our code with us, and now that we have potential to work on it, we have plans. The first thing we want to do is enhance it on the protocol side of things. Basically, enhance it with TLS, security protocol, and also OpenFlow awareness within the library. The second thing is scale. We want to be able to scale up to 256,000 sessions, flows, and about 3,000 connections between controllers and switches. I think that's ambitious. And finally, the performance. This is very exciting because if we can profile and benchmark, we'll get an idea of how much a part of performance a library like this can aid and help with in an SDN device. And if we can do it with multi-core GPU, that's even better. Any or all of this can be possible with a team of collaborators, and we are inviting all of you to consider joining the team and being a part of this project. The perfect place to start would be a workshop that we have planned in August, and I will get to that in a bit. But some of the technical areas that we are looking at include the programming languages, Git and GitHub, SDN and OpenFlow, and multi-core. But rest assured that regardless of your comfort level, we will help you learn. And that's because the spirit of this project is to learn and research and self-study. And multi-core is not a hard requirement, I should say that. If you have multi-core expertise, that's great. If not, we'll all learn together. Going to the workshop. It's open to all, men and women. As far as the project goes, men could join as well. We hope for it to be a platform where women will feel more encouraged to contribute with open source, but men are welcome. Currently, it's scheduled for August 9, the workshop, and the event is up at Eventbrite. If anybody is interested in joining, you can meet me after the event, and I can send you the link to the Eventbrite, and you can register. So to summarize what I just went over, we have an open source library called OF Connect for OpenFlow network connections. It's currently available on GitHub, and we would like you all to join and help us take it to the next step. Thank you.
Thank you so much, Deepa, for the great insight on OF Connect and the wonderful work that CodeChicks members do. Thank you so much. So now I'd like to welcome Serpil up here. Serpil is a principal engineer at Cisco, and she's a WISE advisor. And she's the driving force behind the Women in Tech speaker series at WISE and the Cisco partnership with CodeChicks.
I'm delighted to see everyone here today. Thanks for coming. And I have met Jan about 5 years ago when I was at Juniper, and he had a short stint at Juniper. He's actually worked at Cisco for a very long time. He's been in the industry for a very long time. But at Juniper, he was writing code to implement OpenFlow for the Juniper's platform, MX 960. That was the first time I had heard about OpenFlow, but shortly after that I realized that Jan has been working in the traffic optimization area for the applications for quite a while. He has a lot of experience working with customers addressing their problems, especially for content distribution. Google and Netflix are the two that come to my mind right away. The way we have been seeing the way SDN is developing, Cisco is looking at it as a network programmability and keep it as generic. What are the kind of things that you can make network to do for your advantage? And obviously SDN is still a very new topic, and we really want to open it up to developers like yourselves. And OpenDaylight is a project that Jan is leading, and we're hoping that that'll be an excellent starting platform. It's an open source initiative, and it's a good playground to write some applications to control the network. And with that, I'd like to invite Jan over, and I want to thank him for volunteering to come and talk to us today.
Is that working? Turn it on.
You still have to hold the mic for everybody?
Oh, okay. Well, thank you very much for having me over. It's an honor to be here and do the presentation to you. So what I'll be talking about today is OpenDaylight. I've been with OpenDaylight kind of ever since it began. It's been a project that has been put together originally by IBM and Cisco, and then, you know, about a year and a half ago, there was the first meeting with the founding members, like the first platinum members that became like the founding members and the founding group of that. A lot of companies, a lot of support in the industry. A lot of companies have joined since. Next slide. Oh, that one. Okay, so what I'll talk about is the SDN overview, then talk about OpenDaylight, the controller architecture and the project itself, and then describe a few applications that we are developing at Cisco in my group for OpenDaylight. So, you know, a lot of people have talked about SDN. You must have heard about SDN. I mean, it's one of the latest buzzwords in the industry, and there actually is something to it. It's really kind of a new and different ways of looking at networks than what we used to do before. So what is it? You know, the first original SDN, and Surplus and my boss David Ward calls it the legacy SDN, is really about control and data separation. And this came out of Stanford circa 2008, where the researchers were trying to figure out how to make innovation in networks go faster. And one of the things that they figured out is, well, we need to separate the control plane from the data plane, because traditionally routers, they have the software, they have hardware, it's an integrated system, it's closed, you cannot do anything with it. So they wanted to experiment. And in order to do that, they figured out this kind of relatively simple protocol between a control plane, which is they wanted to do their own control planes. They wanted to design new routing protocols or new, spanning trees or what have you. And they wanted to use existing hardware. So they came up with OpenFlow, and they separated control and data planes. But is that really what SDN is? So that was kind of the starting point for SDN. Is it really OpenFlow? I mean, it's OpenFlow is a kind of good start for a protocol, and it did what it was supposed to do. I mean, it allowed researchers to experiment and come up with a bunch of new ideas. Now, when it was taken further into some early adopters like Google, they really came up with things like logically centralized control planes. Basically, take whatever used to be BGP or IGP running the network, they put it all in a logically centralized computer. It still is a distributed system running on multiple nodes, but it's a logically centralized system which is controlling a whole network or a whole subnet. And that actually proved to work reasonably well in their environment, which is relatively closed and static. And for what they try to do, that was a really good and very successful use case. They also it allowed them to use wide level switches, which is drive down the cost of their solution quite a bit. So these are all valid and useful use cases, but it's not all. We think we can define SDN much more broadly than just control and data plane separation and logically centralized control plane. The network itself, it actually provides a vast amount of data that can be utilized by network applications. We want to harness that data and devise applications that use it and do something really interesting with the network. We also want to reuse all the software and all the kind of knowledge that has gone into networking in the last 50 years basically utilize the networks in a better way, or optimize them in a better way, or come up with faster, cheaper, more bandwidth solutions and more applications to problems, more solutions to problems that people are typically encountering. One of the kind of biggest problems today with the networks is, since they become fairly complex, their management is becoming a problem, and it requires vast manpower, and it takes a long time to do any change in a network. So one of the things that SDN applications can actually do is automate a lot of the management and the configuration processes that are today done by network operators. So when you look at it, in our view, SDN has this feedback loop where you harvest network intelligence from all layers of the network, and it's the OSI network model, where you got 7 layers from transport going all the way to management and orchestration, and then utilize that data that is collected from the network, and then program for optimized experience. So this generic feedback control policy between applications and a network, that's really kind of the innovation that SDN has introduced into networking, and it's kind of really driving like the newest networking revolution. So now SDN has been around since 2008, and it took until about 2013 to actually create a kind of networking or industry-wide open source project for a controller. So the goal of the project is to build an ecosystem of open source software, SDN software. So it's the controller, but also the applications that run on the controller. And it's multi-project, multi-vendor. So what that means is these are all the vendors as of, I guess, today who are participating in the development of OpenDaylight or are members of the OpenDaylight consortium. We've got the platinum members, which who provide significant funding and also development engineers. And then you've got all kinds of companies, big and small, startups, established companies that either monitor the progress or participate to a certain degree as either gold or silver members. One of the most recent vendors are Oracle, ZTE, HBC. So this is growing, by the way. By every month, there's, or a couple months, there is new companies and new people joining the network, joining the project. So the scope is the controller itself, which is kind of the core of the project, and software for forwarding elements. Southbound plugins for different protocols that the network speaks. The northbound plugins is something that provides APIs to applications and allows applications to talk to the network. Then network services and apps that run on top of the controller. And then things that support the ecosystem, such as tools, testing, and other kinds of infrastructure. We don't do that yet, but that's also planned plugins for intercontroller communication. So these are the active projects. You can see there's quite a bit. We started with like 7 or 8 back in March 2013, and we've got something 20, almost 30 projects now currently being active, with almost 200 developers actively developing code and contributing, committing code. So the goals are, first and foremost, code. So we want to create robust, extensible open source code base that is required to build SDN solutions. We really want to have a robust controller that is owned by the industry, where people can innovate on top of and provide solutions and can work with any vendor's equipment. Acceptance, we want to get broad industry acceptance of SDN among vendors and users. Also, last but not least, I mean, this is really important, is build a community. It's a technical community that can contribute to the code base, can contribute to the solutions, use the code and use the products developed on that in commercial products, and adding value in the network itself, in the controller, and in applications that run on top of the controller. So I'll go a little bit in the architecture overview. Given the definition of the SDN, what should an SDN controller look like? So it's really two things. It's a platform for deploying SDN applications, and it's also an application development environment. When you look at controllers before OpenDaylight, there are kind of more or less closed systems built around OpenFlow, and that's historically where SDN and OpenFlow and the SDN solutions are coming from. They have started with OpenFlow, but networking doesn't end with OpenFlow. So we want to make sure that we can deploy a vast variety of SDN applications that do not just limit themselves to control plane, do not limit themselves to OpenFlow. So, and you can see that some of the projects that are actually being developed on top of the OpenDaylight controller are really far away from OpenFlow. Like two of the kind of most exciting projects that are being developed today. One is the policy, group-based policy project, which defines application-level policies for the network, then translates them into network programming, but it looks at the kind of API into the network, not with networking views, or not from a networking angle, but from the application developer's angle. So you can actually see that things like application level policy can be expressed and can be put into an environment such as OpenDaylight. The other project is service function chaining, and again, this is done together with work being performed or being done in IETF, where a chaining or kind of putting together of value-add services out of individual service blocks is being defined. Some new protocols communicated between network elements are being defined there, and the control plane for that, or the controlling of that, is being defined with APIs and with software being run on top of OpenDaylight. So there's going to be a demo at IETF in Toronto in about a month's time. So that's a really exciting project, and it also shows the kind of a wide variety or wide scope of applications that are being developed on top of OpenDaylight. So this is well beyond the original OpenFlow idea. So for platform requirements, the platform needs to be flexible. It needs to accommodate diverse applications, from the control plane applications, which is kind of the original aim of SDN, to things like policies or content distribution, which is, I think, one of the projects as well. Subscriber management, which is one of the projects on OpenDaylight as well, service chaining and so forth. So a vast variety of applications. I mean, really the sky's the limit, and the imagination of the developers is kind of the only thing that would limit what can be put on or what we should be able to put on a platform. But if we have even different applications and diverse applications, we still need a common framework and a similar programming model, so that once people develop all these different applications, we can put them together on a single platform. So this is eventually going to be a big system operating a network with a variety of applications running on the system, and we need to be able to integrate it, and the operators need to be able to run it. So we have to have a common framework and a common programming model, which also comes to having consistent APIs. If you have consistent APIs in these different applications, then actually applications can start using each other, and you can start doing mashups between different applications developed on the controller and for the controller, and utilize functionality that other people have developed. So kind of foster the evolution of an ecosystem. We need to be able to scale development process. So we've got 200 developers on the project right now, approximately, active developers, and they're distributed literally all over the world. It's 24/7 development, and what we need to be able to do really fast integration. So the system is about 1.25 million line of code big, so it's fairly big. Code is being added every day. So we cannot have hotspots in the system, in a sense, that there cannot be kind of common areas where everybody needs to be working on and adding code, because that would require really kind of closed loop integration, which does not exist in the project and in a distributed system, distributed development environment like this. So we need to be able to enable the developers kind of to work independently of each other, and then integration times, because everybody runs out of time on their own projects, are relatively short. So we need to be able to put it together in a short period of time, because the integration testing, like for what we had for the first release, hydrogen, was really short, and I assume we're going to have the same situation in helium. I mean, there's continuous integration going on, but for the final integration, there will be a couple of weeks, no more than that. For the controller, we need to have runtime extensibility, and the controller needs to be really modular. We need to be able to load new applications and services into the controller at runtime. And one of the things that is kind of maybe a little bit far-fetched requirement, but I think this is where SDN can really shine, is the controller itself needs to be able to adapt itself to data schemas that it discovers in a network. Because one of the problems with managing the networks today through a network management system is when you have features down at a box in the routers or switches, they are accessible through a network management system or an EMS. And in order to actually be able to utilize the features in the network elements, you need to be able to change the EMS. And the EMSs are very complex systems, and they typically lag the development of the features on the box, because there's the box developers, network element developers, they develop the CLIs or they develop the APIs into the system, and then the EMS developers have to go in and take those and use it in the EMS, and then write the REST APIs or northbound APIs to applications, or write the applications themselves. So one of the things that we wanted to do with OpenDaylight is the controller should be able to discover the schemas of the network elements in a network and kind of adapt itself to that at runtime. And finally, performance and scale. I mean, this is really a large-scale system that needs to perform well with a large number of network elements and a large amount of data that it has to manage. Now, for the application development, one really key thing is that SDN is kind of a hybrid between networking and programming. And we need to be able to put together network engineers who understand the networks, and software developers who know how to develop software. And so in order to do that, there has to be some kind of a domain knowledge where the network engineers can specify functionality kind of in their language, and then the software engineers can take that and implement the code, implement the functionality. And so this kind of a domain-specific language is needed for the two kind of different groups to meet. Such language actually, modeling language exists. It's fairly new. It's been in development at IETF, I think since 2006, 2008, standardized in 2010. It's called Yang. It's a Yang modeling language, and it's being used increasingly in network elements to describe functionality. So, some of you may heard about SNMP and MIPS. So Yang is like SNMP version 2, and it's much better readable, humanly readable than MIPS, which have the ASN1 notation, and it describes the structure of network elements, and it can also be used to describe services and interfaces of a system. So a network engineer used to managing systems with SNMP or MIPS or some kind of a structured management information base can understand the Yang very easily. The same is for programmers. I mean, it's a little bit of a learning curve for the programmers, but guys who know JSON and XML can master Yang within a couple days. We also need modeling tools. So there are increasingly modeling tools being available for Yang and its associated protocols. So rather than SNMP, the protocol that talks down to network nodes is called NetConf, Network Configuration Protocol. And so the tools to align the modeling or the description of the functionality in network devices and in the controller should be the same. So by choosing the same language on the controller and the network elements, you align kind of the description and the functional specification of the kind of entire networking layer from network elements all the way to applications. Once we have the models, we can generate a lot of code that would normally have to be written by hand from the models. We are generating a lot of APIs out of models. We can enforce standard API contracts. A lot of boilerplate code can be generated for repetitive and error-prone tasks. We only have bindings generate code for Java today, but it's conceivable and probably it will be started sometime soon. Different language bindings, probably Python is like the next in line. And you can start automating more and more things for which code has to be manually written today, like adaptation between different models and services and models. So you can create tools where you specify in some kind of a higher level language how to adapt one type of model or one model into another model, or map a service onto programming of a network element. And rather than writing code for that, you can just specify the mapping in some kind of a high level description and code can be generated for you. And yes, we should be able to consume the aligned device models. So we've got a kind of a layer in OpenDaylight which we call service adaptation layer, and the MD stands for MD SAL, and a lot of these concepts have been kind of instantiated and implemented in that MD SAL layer. I'll go to that shortly. This is actually the architecture of the controller. Any questions so far, by the way? You can make it a little bit more interactive if you'd like. No questions? Yes?
You just mentioned about MIPS and SNMP, right? Basically, I work on SNMP. Now, just wanted to know, like, what kind of similarity or what kind of similarity or transfer we have in the model that we have for, let's say, SNMP onto the SDN or this platform that you mentioned in the slide.
They both describe, SNMP is more like table oriented, where you've got tables. Yang describes the management information model as a tree. So to Yang, everything is a tree, management information tree. If you know XML, you know, like a structure of an XML or a DOM document, Yang defined data structures very much resemble to an XML or JSON DOM document. Okay, and there's also actually bindings. XML on the wire, I mean Yang on the wire, you describe, so it's a more humanly readable XML schema with richer semantics, richer syntax, and somewhat richer semantics. So XML schemas are kind of, an XML notoriously difficult to work with. Yang makes that a lot easier, and it translates onto XML on the wire, or it translates onto JSON on the wire.
Yes, and this is basically a tool, right? You mentioned it's a modeling language, or
yes.
A tool. Okay.
So there's a lot of tools that kind of can work with the Yang models. In OpenDaylight, we developed a bunch of tools that translate the Yang models into Java code. So we generate, you define a Yang model, and we generate the Java APIs out of that Yang model. And we also generate translations, and we generate code that works with Yang-defined data, so it can take the XML or JSON from the wire, translate it into an internal format, and put it in a database, or move it around the system. And can translate also between XML and JSON. So all these things you kind of get automatically generated in a system from one common set of models. Yes?
So does OpenDaylight use Cisco One platform to kind of provide the standard?
No, it's completely open source. Okay. And it has been evolved from a Cisco contribution called XNC, which was the original Cisco contribution, but it has been vastly evolved since. So, principles from XNC are still in OpenDaylight, but there's been many contributions by many companies, and it's a true open source project. Yes?
Does anything need to change in the network elements for them to be able to talk to OpenDaylight, or is the interface, or if they speak Yang?
That's a really good question. So, OpenDaylight has kind of, been, so we are trying to skate where the puck is going to be rather than where it is right now. So we think that this principle of netconf and Yang is going to take off more and more, and you can actually see it in more and more vendors' equipment as Yang and netconf are being adopted, and it's starting to be a requirement in a lot of customers that are starting to require this. So we assume that eventually you will have model-driven capabilities in the network elements. Right now, there are a few Cisco's developing a lot of netconf Yang capabilities in the network elements. So, in short, yes, the architecture is geared towards that, but you don't have to have netconf and Yang in the network elements. There is also kind of translation plugins at the bottom, which can translate the kind of internal models that OpenDaylight uses into CLI constructs, or into OpenFlow, or into PSEB, or into any kind of other protocols that the network elements can talk. This was actually one of the requirements when OpenDaylight was architected, is that it can talk multiple different protocols at the bottom. So these plugins that you see on the southbound, we call them protocol plugins. They normalize the different languages or the different protocols that the network elements talk, and normalize them in a common kind of internal model that OpenDaylight uses internally, and then exposes that to applications.
Yes. Maybe it's worth mentioning that netconf is being requested actually independent of the OpenDaylight. Any new modern management systems in the networks, you tend to require netconf. Okay.
It's actually, again, like we are seeing this model-driven approach more and more, and people are, more and more companies. We see that mostly in service providers, starting with this approach. But there was an article on SDN Central just yesterday where Google is looking at model-driven approach to networking, and they say they will be driving standard models of network devices through the standards bodies, and they are thinking whether Yang is the right language or not. So. It's starting to take off, even or some of the SDN pioneers that have started with OpenFlow are now looking in the model-driven approach. Yes.
Can you briefly explain how the legacy protocols like BGP work with the SDN architecture?
Yeah, I have actually a couple slides for BGP. You know how well. I can explain how they work inside OpenDaylight. BGP can be used for different things in SDN. Where we use BGP in OpenDaylight is actually to get information out of the network through a protocol BGP extension called BGPLS. So BGPLS, again, like was originally developed at Juniper for getting IGP topology data out of the network through BGP. But we are starting to see drafts in IETF to expand it to all kinds of other information, like getting segment routing information out of it or getting LSP information out of the network. So BGP is actually quite a useful kind of dissemination protocol that can be used to get information out of the network. And we in the OpenDaylight controller, we actually use BGP in this fashion. It's basically, it's not to do networking itself. I mean, that's what the routers can do really well, and we don't need to supplement that. But we want to get information out of the network and augment the routing, augment the control plane in the network, and we use BGP as one of the interfaces to the network, or BGPLS. Yes?
So what are some of the applications that the users of this build, and is that open source as well?
Some of them are, yes. There are a couple of projects that do like network virtualization, and it's a project by NEC called VTN, or a project by IBM called OpenDAO. Then I think some of the projects that I listed there, there are applications as well. There's a project for doing a GUI or visualization of network information that's called DLUX. So yes, these are starting to crop up as well. So the controller has 3 layers. It has the southbound protocol kind of layers, southbound protocol layer with different plugins that talk different protocols, different APIs down to the network elements. Then there is this adaptation layer. Then there is actually service and network functions in the controller, like topology and inventory, because the controller kind of has to do some of the EMS and MS function as well, or supplement that. And then some service functions in the first implementation. These service functions are related to OpenFlow, like statistics gathering, forwarding rules manager, where you can program flows into the network, into individual network elements. But it projects a common API, kind of a network-wide API to applications. And then on top of that, there are REST APIs. In the OpenDaylight case, the REST APIs are also generated, actually not generated, but rendered from models. So developers specify API functionality in Yang models, and then the REST APIs are rendered out of that automatically, and it doesn't really matter whether a plugin is internal Java function and accesses the functionality defined by the API from inside of the controller, or there's an external client. It's all the same API, but projected in 2 different ways as REST and Java APIs. So the REST APIs, there is also an IETF standard for how the REST APIs are rendered from models, and that's called RESTconf. From software perspective, the controller actually looks like, from a networking perspective, the control looks like 3 layers, like something that's talking to the network, an adaptation layer, and then something that is talking to the applications. But when you look at it from a software architecture view, there is actually no difference between the plugins that talk to network and the plugins that talk to applications. They all look the same. So basically the SAL is kind of a backbone of the whole system, into which protocol plugins and modules kind of are hooked into, and they can talk to each other and do adaptations. Because that's basically what a controller does. It connects network devices with applications, and it does need to do adaptations on a way. And then within a container, we've got the SAL and the RESTCOM and the plugins, but we cluster the individual instances of the controller through a messaging bus and a data store, like putting together multiple instances of them to work as a single node or a single controller. So what the controller is actually doing, and this is a statement about the modularity, is it is dynamically building the network view, and it's different applications and different plugins in the controller that put together and stitch together this network view. So the BGP topology exporter, it creates the whole network view in Yang and in kind of any other network management system. It looks like a tree. And different branches or different subtrees in a tree are created by different applications. So the topology exporter creates the topology trees. The OpenFlow topology exporter creates the OpenFlow topology. Inventory manager, that's another component in the controller. It creates the tree of OpenFlow nodes in the system. And the application then sees the tree, and it can change the individual values in a tree if it, for example, wants to program a flow or delete a flow. So it's really all about manipulating and changing management trees. Statistics for OpenFlow nodes are actually collected by a different component, not by the inventory manager, but that different component is stitching together or putting branches into the OpenFlow node subtrees. So you can actually see that different independent pieces of software can cooperate together on creating a common view of the network. So it's very, very modular. And the different views of the network are defined as models. And when you look at it, actually, all these different components have been developed by different developers, so and different groups of developers. The statistics manager has been developed by a person in India. The flow capable, the inventory manager, that has been developed by, I think, between somebody in San Jose and somebody in Eastern Europe. The topology exporter is BGPLS, that's been developed by guys in Eastern Europe. Actually, it's been developed by the leader of that project. That's a girl or a lady, a code chick. She's the fourth most prolific contributor to OpenDaylight. So when you look at the number of contributions, she's number 4. So there is a representation of that, and we've got some top contributors in OpenDaylight. So, but you see the modularity, and you see how kind of the information about the network for applications is actually being put together by different components in the system, developed by different people. And they have to meet at the different definitions of the APIs, and this is where the model-driven approach helps. The models are defined, and then they work towards common APIs, because the whole structure of the tree is defined in basically in a Yang model. And then with netconf, I mean, netconf adds the netconf capable nodes to the inventory. So this goes into the detail of the SAL. I won't go into that in this talk, but rather spend some time on applications and use cases. So you ask about the BGP, how we use that. So we get a BGP feed out of the network. What that BGPLS component at the bottom does is it translates the BGP feed into, actually fills a BGP RIB. The BGP RIB inside of OpenDaylight is defined, again, like as a Yang model, just like everything else. So it translates the BGP PDUs and then creates a BGP RIB in OpenDaylight. The RIB is defined as a Yang model, and code for that is generated. So it's Java code actually generated for the structures and you know how that whole thing is put together. So the BGP PDUs come in, the RIB is built up. The BGP RIB here, it contains the BGPLS and LRIs. So there is a component, again, like independent component of the BGP, called BGPLS topology exporter, that takes the data from the BGP RIB, it understands the BGPLS and LRIs, and it stitches together the topology. And then it puts it back into the SAL, again, in a format defined by a Yang model, by a topology model. So it creates one or more topologies depending on what data it gets from the network. And then applications can actually get that through RESTconf, the applications that need to consume the topology. So you can see kind of a two-step process for decoding the information that comes from the network. Now, if we want to use BGP for something else, like VPNs or what have you, then instead of the BGP topology exporter, we would have some kind of a VPN manager sitting next to it. But the code for BGPLS and for the RIB, that would be 100% reused. The same for the different topologies of the topology exporter. So OpenFlow topology exporter is a completely independent component, but it generates a topology in the same format as the BGP topology exporter. So the application that reads the different topologies again sees them in the same format.
One question.
Yes.
So does this mean that once we migrate to SDN, the TCP/IP stack still exists?
Oh yeah, absolutely. Nothing changes there.
Good.
We're not here to abolish networking, we're here to complete it.
I'm worried that TCP/IP.
No worries. Nothing would work without TCP, So even if you have like OpenFlow, I mean, it's on top of TCP. Right, so that's the foundation. Nothing can change on that. What really changes, it's really about being able to, because a centralized entity, such as an application that works on top of a controller, has a better view of the network than the distributed control plane. So it can optimize better, it can apply policies better, but still, in case of failures or in case of, when you go down to the individual network elements, you have to have that distributed aspect to it as well. So things that are in a network today, they kind of won't go away. I mean, they have to be there. And even if you lose the connection to the controller, the network has to operate in some kind of a mode. So the controllers and the applications run on the controller. They do augment what the network does today, which is the basic transport, and that doesn't go away. And that includes TCP, that includes all the plethora of IGPs and BGPs that kind of put the network together. So that won't go away. So this is an application kind of closer to OpenFlow, and it again shows how the different components in the controller interoperate. So when a message comes in, the SAL actually is also like a message bus or a routing entity. So it routes the event. So the message coming in is translated into an event in the controller. The event is routed to the appropriate application. In this case, it's the learning switch application. And the learning switch application will do two things. It will flood the packet out, that's the kind of specification of the learning switch, and it will also install a flow. And it will install a flow into kind of a common database that sits in the SAL, and that will cause the FRM that will trigger the FRM to actually go and insert a flow mode down at the appropriate switch. So again, the interoperation of the different components is driven by the models that have been defined for these components, and then they have been implemented by different people, the library and plugin. The plugin is being implemented by people from 3 different companies. The learning switch is implemented in the FRM by somebody else, and it all has to work together and be integrated. And again, like we found that this integration on top of the common APIs or common understanding really helps to shorten that out and actually enables this kind of development. So the teams don't have to be tightly coupled. This is the policy group networking project. This is to implement policies. This is a Cisco specific project where we've got a device called ICE, which is mapping users to what we call policy groups in the network. So it basically defines kind of like virtual networks or virtual dynamic networks in the security networks or security groups in the network that define who can talk to whom and with what quality of service and so forth. And basically working with that is an application that when a user connects, he gets a certain quality of service and he gets a certain rights of what he can do with the network. So if a user connects from inside of the company, he can get access to the company servers and order labs and so forth. If they connect from outside, they can only get access to email and the corporate website or something like that. So depending on the location and the credentials of the user, the access of the to the corporate network is very tightly controlled. So this can prevent, if you have followed like a couple of months ago, 3 months ago, there was a security breach in Target. It was some kind of a contractor, external contractor that got access to the servers. So with this kind of an application where it tightly controls who can access what and dynamically gives rights, something like that is not possible. I2SS, it's a little bit of a misnomer. It's actually, it was originally a subscriber system application, but what it is in the end is a automation of network configuration. And basically what it does, rather than, because today when a user or a new CPE is connected to the network, then you have to open a trouble ticket, they have to go in, they have to configure a whole bunch of routers, they have to figure out where the user is connected. Then once the connection is done, the user has to go to a portal or has to open another trouble ticket, activate the service, do the billing, what have you. So it takes weeks until a service can be brought up. What this application does is it reduces that process literally into like a couple of minutes. So when a user CP arrives via email or FedEx, user connects it to Ethernet, the device kind of dials home or does DHCP. The application running on top of the controller catches that and figures out where the new CPE is connected to which router, configures the user's VPN or E-line to the data center where the user needs to go, and then the user can go into a self-service portal, activate it, and be up and running in a couple of minutes. Huge savings and huge speed up of configuration. So this is really kind of the value, the automation and the zero touch, where SDN really shines. And this is just showing kind of a generic service adaptation where you have different vendors have different models in their devices or have different ways of providing the same functionality on the device. Some people do it via OpenFlow, some people do it via ACLs, or they have different CLIs. So the controller can be used as kind of a normalizer for applications that creates a common service model for different features on the boxes and then translates that to the individual device specs. But as we also see, actually, there's a thrust in the industry to start coming up with common network models. So there will always be adaptations, and we will start seeing the more and more kind of common standardized device models as well. But if you don't have that, or you have legacy devices, then with this modular fashion, where you can have different adapters, again written by different people, independently of each other, can normalize functions from different devices onto a common model projected to applications. So a few more things about resources and OpenDaylight. Please do remember the website. It's wiki.opendaylight.org. There's a lot of really interesting technical information. There's also information on how to get started on the code. So there's how to get started for the developers, how to pull down code, how to build the controller, how to run it, get the basic GUI going, and how to start a basic hacking. Also, a lot of the development actually kind of happens on the free. It's a bug. It's a free node, not free none. On IRC channels, there's about 3 or 4 IRC channels now where developers actually discuss with each other things. There's mailing lists. There's also, I think, Twitter and other accounts where you can get information. But most people actually use IRC. So please do participate. That would be awesome. Great job on that. Open source is really the standards for the 21st century. So it's we can see it that some of the standards bodies, they develop standards are a little bit detached from the code, and open source software brings up the the best ideas, and you've got the immediate implementation of some of the ideas, and the APIs and the ways how open source does things become the de facto standards by the fact that people just start using that. And we've seen that not with just OpenDaylight, but we see it with all kinds of other open source projects, like, I don't know, Hadoop for MapReduce, or Cassandra for DHT's KV source. So Amazon Web Services, OpenStack. So there's a lot of examples of that, and we will probably keep seeing more and more of that. So open source is really the way to go, and really the way to come to some kind of common ways where industry can get around and create a solution. Any questions? Yes.
I just wondered how it can be used or not used for net neutrality. Like, how is it affected by that or not, or does it affect that?
Net neutrality is a policy that the vendors, the operators implement. OpenDaylight is a technical solution that can be either used to foster it or to suppress it. Right? So you could equally use it in each use case. For example, control the network to be more open, or create an application where, depending on who the user is and what they do, give them better quality of service. So
it makes it easier to control.
It makes it easier to control. Yes, that's true. But again, I mean, then what do you do with it? All right. So it's a tool, and it can be used or it can be misused. But yes, it makes easier for operators to deploy policies, and the policies can be good or bad. That's a good question. Yes?
How do you see the providers using, how much of their network will they open up to the application developers? How do you see that evolving going forward?
That's a good question. It probably won't open the networks directly, so there will never be access to network elements. There may never actually be access even to controllers that control the network elements. So apps kind of on the outside will probably be like a couple degrees remote. But I think we will see kind of more and more even like companies developing applications for controllers. Once the controller platform is more prevalent, the service providers, they do always validate and have to verify and certify any kind of an application that goes in here. And this is the controllers, they do give the capability to applications, to an uninformed application, to actually maybe even bring down the network. So what I actually see is with the controllers, and this is one of the ways that or one of the things that we don't work right now, but we know it's on the roadmap, is so-called virtualization of the network. So basically, given the different credentials of an application or an application developer, you allow the application to do different things. So once those capabilities evolve, then the service providers will probably open it up a little bit more and to even like third-party applications or doing something. For the reading and doing analytics, it's probably not as critical, but as soon as the app does go in and does provisioning, that all needs to be validated and checked whether the app can do it and whether the app actually knows what it's doing. But what we see is some of these apps and things that are being developed are really complicated workflows that the service providers probably can't really develop all by themselves, which they used to do. So there is room for a lot of third-party developers and third-party applications, and we will see more and more of that. Yes.
So among the applications that we have right now, are there any applications for sort of self-correcting the network? Like it can detect the problem on its own and try to implement a solution to?
There are requirements from service providers to do that, yes. I'm not personally aware of any apps, but yeah, kind of along the lines, yes. We see that from the most forward-looking service providers. They want the zero touch, so when an application or kind of this real-time system or ecosystem that they want to build on top of the controller, they want it to be able to detect problems and then self-correct the problems with whatever action is needed. So the zero touch is a requirement. Because when you look at it with all these service providers, the IT and the management of the network is now the major component in their OPEX or in their cost of running the network is really kind of the human factor and the factor of developing all these kind of systems. So we're working on some of these systems where there is like a zero-touch complete automation.
And apart from the service provider network group, as in the market you see, or do you know of any other, like in enterprise market or in the data center switching, is there an application?
We see the same thrust and the same trend in the enterprise networks as well. I mean, there's a lot of desire to just have kind of complete solutions where the network operation is automated, because it really is complex, and it's kind of starting to get beyond understanding of a single CCIE or a single network expert. So it is a problem to operate a network these days, be it enterprise, data center, or service provider.
what do you think is the future of the current standards, all these protocols, things like that, after the advent of SDN?
We will still see proliferation of standards and protocols, just like we've seen today. So, and you know, the Darwinian process, so we will see new protocols and standards coming alive, and then, you know, the process of the useful ones being used.
I guess my question is, if we want to adapt to this new standard, SDN, what do we need to focus on as an engineer? Like, we are doing all these protocols, like routing protocols, switching, etc. So, what should we focus on going forward?
It's really I don't think these protocols are going away. This is my personal view, you know. So the protocols are kind of not interesting, because the protocols is just kind of the way you get bits in out of a system. What's really interesting is the information models, and then figuring out what you can do with the information that's described by the information models. So I think it's really in the apps. So
for some people, apps are boring. Protocols are interesting.
Yes, I know. I know that's what I'm saying. I mean, this is my personal opinion, right? So the protocols are not going away, and there will always be need for new features in BGP or in IGPs or in I don't know, the data center protocols as well, and you know, maybe new formats. I don't know. Like segment routing is an example of that. I mean, there's a really great idea recently. You know, it simplifies a lot of the operation of the network. And it required a whole slew of kind of new protocols or modification to existing protocols to make it work. And you know, it's work that has gone on for a couple of years, and it will go on for several years going forward. So there will always be something like that. But compared to, say, the wealth and breadth of applications that are going to be possible or should be possible to work with the data that we get from a network or operate a network, the protocols is a relatively narrow field. There will be innovations in there as well. I mean, it's just innovation never stops. But again, I mean, it's I think where we're going to be seeing most innovation going forward is in the network applications, kind of running on top of the controllers, because that enables the kind of the widest community. I mean, protocols is a relatively small and closed community, and it's a very big hurdle getting in. Once you enable the functionality of the network through REST APIs, and people will come up with ideas I never thought of. Yeah.
And so one of the perspectives of the controller is as a policy dispenser, right?
Yes.
But on the other hand, it's in a really good place to amass a lot of information out of the network.
Yes.
In terms of traffic and runtime data on traffic.
Right.
So do you envision a Facebook kind of a model where that kind of data can be traded, for example?
That's an interesting idea, yes. Technically, I think it's possible. Maybe even business, but the providers right now, they kind of guard the data that they gather very, very closely. But if there is, if there can be a marketplace, which I don't know, then something like this is certainly possible. So the question is, what would it be traded for? And what would be the advantage of trading this information? So once a provider or an enterprise can get some good price or good money for this information, or get some advantage for divulging this information, then the marketplace can originate in that.
So is there currently any analytics or any?
Yes, there is a couple of analytics applications that have been written for OpenDaylight and or for other controllers. So that's kind of one of the primary applications for collecting and analyzing data.
And that must be the closed loop.
That's the closed loop, exactly. So there's apps that collect the data, warehouse it, and process it, and then there's other apps that will be then taking the data and programming the network. We've got one application in Cisco called WAN Optimization Engine, which actually does the whole loop. It basically collects the data on how the network operates and then optimizes tunnels and programs the tunnels into the network. Yes?
So what means, so the YANG modeling language seems like quite effective and then can dynamically reflect the operational status
yes.
at that time. What needs to be better for YANG modeling? I know this is in the past there are lots of modeling efforts for network admins, right? But then they will always have some difficulty, either for distributed network modeling or runtime rendering. But it seems YANG it's quite promising.
Yeah, it seems quite promising. I mean, it looks like a fairly good modeling language that can be used to model a wide variety of services and problems and describe a wide variety of problems.
Now, what others need to be addressed?
What else need to be addressed? There are some improvements to YANG going on in IETF, but that's like details, to improve the language itself. Again, like from the tools, maybe more extensive generation of code, because we're kind of in the beginning, and better mapping of YANG onto APIs. Eventually, you actually want to get into even higher, because YANG is still fairly low level. You want to get into higher level languages like policy description languages. We do describe policies today in YANG, but it starts becoming a bit cumbersome. So we will eventually need higher level policy languages to describe policies.
It's more relationship always.
Yeah.
And also think about the OpenDaylight and the integration with the OpenStack, right? That is so it's more likely integrated with the Neutron for the orchestrator to have
yes.
a system-wide view of all the networks. So that probably can fit into dashboard, so can see from not only compute storage as well as
right. So there is a Neutron plugin into OpenDaylight, or plugin from Neutron into OpenDaylight. So that's one of the projects, is how to hook OpenDaylight into OpenStack. There's a bunch of people working on that. Yes.
So I participated in the One Night Stand hackathon that happened in March. I think
okay.
David Ward was one of the organizers. So there was a lot of good energy. It was very exciting. And after the hackathon, I tried going to the Daylight wiki.
Yes.
And I got the code. I started browsing through the code. But I didn't know exactly, what to start with, like some concrete starting point, whether it is documentation or bug fix or something, to get a foothold. Because it's sort of daunting when you start
yes.
off on such a huge
yes.
code base. What would you suggest would be a good place to start, whether it is documentation or?
The documentation and tutorials are being put together now. When you look at what do we have, June now, in March, it was god awful.
Right. Yeah, I didn't see that much.
Yeah,
and
it's daunting, and without somebody actually sitting with you and explaining how to get in, it was virtually impossible to do. But there's a bunch of people working on usability and working on tutorials, and there's been vast improvements. So look at the toaster tutorials in the wiki. Then also there has been an archetype created where basically you just run it and it creates a skeleton of an application for you. And you can deploy it on OpenDaylight, and you can hack it. You can kind of change it and see what it does for you. This all didn't exist like 4 months ago. It's been put together recently, and it's still, you know, quite a few people actually that recently joined the project are working on that and improving both the documentation and the examples and the tutorials and kind of the automation of bringing new people on board. So our goal is here to kind of, you go over the lunch break within an hour, you know, you can get something up and running. So we're not there yet, but you know, it's check the toasters now, and in a couple of months, you know, it should be, we should have these really kind of easy starts, lunch hour start, you know, like do something with OpenDaylight, like do a Hello World. In a really easy way, and then start snowballing that. So that's being worked on now. It's a good point.
Yeah, thanks.
Yeah.
I have a related question. So if an app developer wants to try something out with audio, obviously there is no, do they build their own network to try it out, or is there something?
So they have Mininet for OpenFlow, and then also at Cisco we've got, we're putting a lot of things on DevNet and on, what is it called? What Niklas is working on?
dCloud.
dCloud, yes.
Would that be open to
generally?
Code jigs?
I'm pretty sure, you know, that we need to talk to Dave and make sure that we can open it up.
Because that's one of the obstacles, right? If you're
Yeah.
dealing with a network and you don't
So,
have your own network.
There is Mininet that you can, there's the OpenFlow network that you can run on your laptop, and that's how most of us do kind of the simple testing and OpenFlow testing. But for, you know, the netcom stuff and, you know, the like kind of more complex networks, you do need the more complicated gear, and that will have to be done on dCloud or DevNet. So we need to make sure, you know, that we got it up there.
Virtualized routers to run
exactly.
your application.
And we've got that. It's just not public, right? We need to make it public.
I think we are out of time.
Should we take
yeah, maybe one last
No,
question.
I just wanted to know, because now we are that this moves everything to software, what is the security implication? Does it get worse? Or are there things in place for?
Yeah, that's another good question, good research area as well. So it opens up new attack vectors that need to be analyzed, and, you know, make sure, you know, that
When we build OpenDaylight, to be planned for that?
yes, there is a security analysis going on. It's actually headed by another girl, Meenakshi, and she's doing a great job at that. So yeah, the whole security initiative in OpenDaylight is led by Meenakshi.